My blood flow restriction research and the research of our team here at the university is focused on how we can use blood flow restriction to optimize exercise countermeasures for astronauts during spaceflight missions, including post-flight reconditioning. So we're exploring how we can use blood flow restriction to reduce the intensity required for positive adaptation, which leads to good health outcomes in these astronauts. Blood flow restriction exercise broadly involves the use of a personalized tourniquet system, which involves a tourniquet cuff, which is applied proximally on a limb and connected to an inflation device. And the idea is that we're targeting or trying to compress the limb and all the underlying tissues, specifically the blood vessels, and we reduce the supply of blood and oxygen to the working muscles during exercise. And what we know is that when you perform low intensity exercise by itself, it's not typically beneficial for positive adaptations in terms of health. But when we perform low intensity exercise with the addition of blood flow restriction, it exacerbates the acute psychophysiological responses to exercise, makes everything harder. And over time, when we apply this chronically as a training intervention, it leads to superior positive adaptations in the muscle, cardiorespiratory and vascular systems. So much so that there's a lot of evidence now that suggests that these adaptations with BFR exercise are comparable to what we get with high intensity exercise, which is traditionally recommended as a requirement to achieve these positive health benefits. One of the key problems now is that as we look to progress beyond low Earth orbit back to the Moon and Mars in what is called exploration class missions, this puts a lot of constraints upon the use of exercise. So there's less time available, there's less equipment available, and it's going to be harder to perform high intensity type exercises. So we're exploring how blood flow restriction can be used in a way that makes exercise more efficient by using lower loads, lower intensities with the addition of the blood flow restriction to keep astronauts healthy and enable them to perform well in space.